All right, here is the real deal factoring. All right, the only process you'll need for this. So you see you might have seen lots of different factoring processes, but I'm going to show you one that just works for everything. Okay, so in order to figure out this process, let's see why it makes sense. Okay, so the reverse process of what we're trying to do, of course, is multiplying the stuff out, collecting my term, and so on, getting the standard form of the quadratic, right? So we're looking at trying to figure out how to reverse that process. We're going to factor. We're going to start with something like 6x squared minus 13x plus 5, and we're going to end up with the two factors. Okay? So if we're looking at the number pattern, okay, we have a 6 and a 5 out on the ends. And if you look where they would have come from, would have been from that 2 times the 3 to get the 6, right? Which we did as part of our distributive law process. So the 2 times the 3 gives the 6, right? 2 times the 3 gave the 6. And so we're noticing that. So really the 2 and the 3 are factors of 6, which yesterday we talked about factors of numbers nonstop, right? So it's not surprising. When you're factoring, you look for factors of numbers. The 5 and the 1 must have given the 5, of course. So we're looking for factors of 5. So all you're ever going to need to know for factoring is factoring by inspection. Your starting point is to put the n numbers, the 6 and the 5. So let me orange. So the 6 and the 5, right? We're starting with those numbers as like headings. Okay, those are our n numbers. Below those, you're going to write factors of them. Okay, so 2 and 3 or 6 and 1. And then 5 is just 5 and 1 because it's a prime number. Okay? Once you have those written, obviously in the process here of multiplying, let's look at this part right here. Okay? When you're multiplying, the 2 multiplies onto each, and so on. There's multiplication going on, right? So you can see that happen in the process. I'm going to show you next here. Is that this is just repeat. The top part's just repeat. We're looking down here where the star is, down here. You need to pick pairs of numbers, right? If you have the right pairs of factors, so the 2 and the 3 and the 5 and the 1, if you have the right pair, then when you multiply them, like it's happening with this process here, right? The multiplications of things, you multiply across, you get products, you get results that add to the middle number. So the middle number here, the 13, if that's the case, then you know you have the right set of factors, okay? It's the right set of numbers. And then all it is you're going to have from here, let's go purple here for this, these are your x numbers, because this is the number that was with x squared, right? With the x's. And these guys are, I'm going to call them just your other numbers. Okay? So in here, for this question, we would have had the 6, the 2 and the 3, right? The 2 and the 3 in there as the x numbers. So 2 and 3 x, so 2x and 3x. Shouldn't have put, wanted to do the color coding for the specific those numbers. So I'll keep the generic format is we have always this bracket, and even actually the x's. I'm going to put those as black as well because they're always going to be there. You're always going to have something with an x, something with an x, and then you're going to have the other numbers. Okay? Critical part of this process is to notice that the 2 has to be able to multiply onto the 5, right? So the 2 has to be able to multiply onto a 5. So picture how if the 5 went here, that wouldn't be good because the 2 wouldn't multiply. The 5 has to go over here. Okay, so the 2 must, has to multiply on the 5. Right, so the 5 has to be over there. So you're like, okay, so the 5, which is a plus 5 in this case, has to be over there, and then the rest of it just falls into place. The 1 has only other one spot to be, right? So the 1 must go here. Your other numbers are going to go, obviously, in these spots here, your other numbers, right? So your other numbers. And of course, The purple ones were your x numbers. Okay, so that would work. That'll, if you multiplied that thing all out, it would give those values. And in fact, if we look back, that's what we started with, right? We had 2x plus 1 and 3x plus 5. Okay. So just word to the wise here, like if you happen to have them written in a different order, and you'd multiply across and you get 15 and you get 2 and you add and get 17, you'd be like, that doesn't match, right? So thumbs down, doesn't match. But you don't have to rewrite anything. You could just do another multiplication. You could do a crisscross multiplication instead, in which case you'd get now the blue one here. This is just old news, right? This is the original one. The blue one gives you a 10 and a 3, which does add to 13, right? So then you do the same work. You're like, okay, so this works, yay. And then so you say the factors, right? Let's say here, factors are, and you're always going to have this format, an x and an x and a number and numbers everywhere else, right? So you're going to have, let's just slap in the 3 and the 2. Doesn't matter what order, right? So let's do the 3 and the 2 as in the order they were. Now we have to make sure that the 3 multiplies onto a 1, right? So you can get the 3. So the 3 has to be able to multiply onto a 1. That other bracket is important, right? So if the 1's there, then the 5 must be in the other spot, and so they're still the plus numbers as they were, and so on. Notice again, 2x plus 1 and 3x plus 5. So what if you didn't pick the right numbers? Worst case scenario here, you didn't even pick the right numbers. So you'd try straight across and be like, oh, 30 and 1. Wow, that's not working for us. Sad face, right? And then you'd try crisscross. You'd be like, okay, let's try this way. Maybe we'll get lucky, right? So that would give us a 1 times a 5 is a 5, and a 6 times 1 is a 6. You add it up, you get 11. You're like, I'm closer, but still no good. So at that stage, don't give up. You just have to try a different pair of factors. Obviously, we've done this one, so we know this one will work, right? So instead of 6 and 1, it turns out the 6 and 1 were just the wrong pair of numbers, right? So you need the correct pair of factors for this to work, right? Yeah, so what do we have here? Oh, yeah. So basically, that'd be great if you got that one next. Or, maybe you get this one if you're really unlucky and you get your 15 and 2 as we looked at, it doesn't work. So then finally, you try the new order with the new numbers and you get it. So it's a possible fourth attempt to get the right answer. Okay, key is just not giving up, right? This might be your first attempt, first try. I love to see that labeled, by the way, in your work. First try, second try, right? Maybe this was your third try, but you kept going, you're sticking with it, and fourth try. And they're like, yay, finally I got it. Okay, that happens. So in these ones here, I'm going to introduce, they'll be a little bit easier because of the 1 in the front, but I'm going to introduce the idea of the negatives and so on. So let's just do this one quick. We know we're going to have the format of x and x, like basically x plus something and x plus something, right? So we know that is what we're going for, right? So let's do it. We got the 1 and the 2 from the ends, right? The 1 and the 2. I should actually circle positive 2. Make sure you see like that whole thing there. You've got to make sure to get that number, especially because we're talking about negatives on this page, right? But I don't normally write the positive there. But 1 and 1 and 2 and 1, there's no choices. And also, there's no way to have the first combination not work because 1s don't matter. They're the same. Right? So we get that adds up to a 3, and you're like, yay, it adds up to a 3, so we're good. And so then you just factor it. You say, okay, we've got 1x and 1x. So if I was doing this from scratch, I would say, so we've got an x and an x, 1x and 1x in other words. And then we have a 2 and a 1. And it just, at this point, for this one, doesn't matter what order they go in because they're both 1s. Okay, so that's what you're going to see there. 1 and a 2. Or a 2 and a 1. Different orders, doesn't matter, of course. This one, we've got a 1 and we've got a minus 8. Oh boy. Don't do it to me again. Minus 8. So we got a minus 8 and a 1, right? Factors of 1. Factors of 8. Let's try 4 and 2. It might be 8 and 1, but usually it's sort of the middle ground numbers, right? And so what I'm going to show you is we're going to put the negative in once we can tell where it needs to go. I'm not putting a negative in yet. A negative needs to be in there somewhere, but we're not sure yet where it needs to be, right? Especially when it's not ones. Now, so when we multiply across, I'm obviously just going to get 4 and 2, but we know that we need to multiply as part of this process, so we may as well do it here, even though it's just ones. So if I have the 4 and the 2, we know there has to be a negative, right? Somewhere, right? In order to get negative 8, it has to be either there or there. So you can just say, well, if I put it on the 4, then I'm going to have a negative answer. I'm going to have a negative 2, as I should have, right? So you can tell you've got the right set of numbers, in which case you have to just say, okay, well, that had to be a negative 4 in order for this to be the correct numbers, right? So that means then we can just fill in here. This underneath there is the right answer, but let's just show that we can do this. We've got x and x. I didn't leave enough room for number signs there because the smart board's out of alignment again. So we've got 1x and 1x. Actually, it didn't matter because it's ones anyways. 1x and 1x, and then a minus 4 and a plus 2. Right? You have the same factors. Could be a different order. Could be the same order. Doesn't matter at all. So it happens to be the same order. So that's one negative case where we end up with a negative in the middle. Now, if you notice, that's because this number was the negative one, the bigger one, right? In this case, we're going to have 1 and negative 3. We're going to have a 1 and a 1 and a 3 and a 1. These are super easy to have prime numbers, right? There's no choices. But we know we need to have a negative somewhere. Okay, so if I put the negative somewhere, I don't want to commit to it yet. I just want to see, okay, I've got a 3 and a 1. I need to have a 2 as an answer. So that means I need the negative to be there, right? So if this number is negative, then I've got the right combination of stuff. And so I'm going to have a 1x and a 1x, and I'm going to have a 3 and a minus 1. 1x and 1x, yep, and a 3 and a minus 1 in either order. Then the other type here, weird kind of case where we have a 1 and a 12, and they're both positive. So 1 and 1, and let's try 4 and 3. Actually, let's try 6 and 2. I suppose I should. I'll allude to why I did that, right? But 6 and 2 or 4 and 3 would be equal chance of choosing. So if we multiply straight across, we get a 6 and a 2. And if you're adding that stuff up, you want it to be a negative 8. We don't have any negatives, but the idea here is if they were both negative, that would combine to make a positive, right? So there's like a hidden negative going on here, right? 2 negatives made this thing. So negative adds up to negative 8. Okay, so that's the other kind of negative case. So we're going to have 1x and 1x, right? 1x and 1x, and then we're going to have a minus 6 and a minus 2. Okay, so this process just takes practice, especially when you get to ones like this where there's well, in this one at least there's more than one option. So in the first one here though, back to the case where we have to worry about the order, but at least it's not hard numbers, right? So if I multiply, notice there's no negatives at all anywhere. I multiply straight across, I'm getting a 6 and a 1, which adds to 7. You're like, okay, well, that didn't work. So instead, I'm going to go crisscross and get a 2 and a 3, and that does add to 5. And so this is the pair that works. So in my process, I'm going to have a number with x, right? So it's going to be a 3x and a 1x. I don't need the 1. Understood. 3 has to be able to multiply with the orange. Right? The 3 has to be able to multiply on the 1, so the 3 has to be able to multiply on the 1. It needs to be in the other bracket. So that's the factored form of that. Back here, by the way, I just point out here, I was going to do 4 and 3, but then I noticed that 4 and 3 doesn't add in any way, shape, or form to give an 8. Whereas 6 and 2 is in my head for factors, and it does add to give 8, so I could tell, right? If I had have done the 4 and the 3 first, 1 and 1, 4 and 3, then I would have ended up with 4 and 3 makes 7. It would have been like, oh darn, that just didn't work. That's all. That just could have been my first try, right? And then my second try would have led to it. So that's basically what I did. I just abandoned ship and should have just stayed with it, I guess. But yeah, that could have been the first try and a second try, right? So let's see what happens in this one here. Maybe I get it first try, maybe I don't. So let's do a 2 and a 12, and let's do the 6 and the 2, the 2 and the 1. Okay, if I multiply straight across, I get 12 and 2, which can't give me a 5 in any way, shape, or form. So basically, you tell like that's not going to work, right? Let's try crisscross. We got a 6 and a 4. And oh, I need minuses too. Let's think about minuses though, right? So a minus somewhere for this stuff, right? We don't know where, but a minus anywhere here won't give us a 5 still, right? So then we're like, okay, over here, could a minus in one of these spots give us a 5? Answer is no, right? So this can't work either. So then you go and you try a different set of factors. So 2, I didn't get lucky that time. I didn't notice that it's harder to notice when you have numbers on both ends, right? So 2 and a negative 12. And so we got 2 and 1, no choice there. What's another factor? 4 and 3, obviously. And so let's multiply straight across, see what happens. Straight across gives me an 8 and a 3. Can that give us a 5? Right? So this one can't give a 5. This one can't give a 5. But this one can, right? If we had a minus here, meaning the minus would have to have been here, we get a 5. So the factored form ends up being 2x, 1x, from here, your x numbers, and then you have a 2 has to multiply onto a 4. 2 has to multiply onto a 4, plus 4, and a minus 3. And that's factored form. Okay, so these all just kind of work out. They're made to be factorable. You just have to find the missing piece, the puzzle, the combination of numbers that work. Okay, so there's a couple more there. The solutions are on the other page, next page of it as well. The numbers of 6 and 4. You got 3 and 2, and notice here you'd have 3 and 2 and 2 and 2, or 3 and 2 and 6 and 1, or 6 and 1 and 2 and 2, and finally here 3 and 2 and 4 and 1 with a negative here and there worked, right? Because we had a minus 4, right? And so on. I don't have that one solved, but I'm out of time. My next class is coming in, so the practice pages are up here. They kind of get progressively harder, where there's one pair possible in each, and so on, and then all the way up to numbers all over the place that could have more than one possible factor. Okay, so give that a try. Factoring takes practice, but the benefit I'm hoping you end up from this is that there's really only that one process to think about. Right, so I highly recommend you adapt to it. I know you probably saw something else in the previous classes, but literally this one works for every case, whereas the other stuff you've seen doesn't. I've been doing this a while. Okay, so please get this process down pat. I'm sure you'll find it to be the easiest you've ever done if you invest some time in it. Okay, hope it works for you. Gotta go. See you later.